and this is pretty easy to do, is y'all all know about right triangles. Y'all know that the sine of an angle is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. And the tangent is equal to the opposite over the adjacent. But here's what you've got to remember about those. Y'all also know that a squared plus b squared equals c squared. And you know 3 more of these, but that's enough of that. These only work for right triangles. That's where you run into problems. So let's look at what happens if you don't have a right triangle. That's what I'm teaching today, is what do you do if you don't have a right triangle? And the good news is Mr. Evans spent money over the holiday, school money, not my money, but they gave us money to spend for school supplies, and I bought $100 worth of markers. Because I really did go through a bunch of these. That was about it. All right, here we go. Not a right triangle day. Now, here's the catch. These rules will work for all triangles. These rules I'm going to teach you today, they actually do work for right triangles. But for not a right triangle, meaning it will work, and it will work for all triangles. It'll work for not a right triangle, but it really works for all triangles. If you don't know if it's a right or not, use what I'm teaching you today. And if it wasn't right, it would have still worked. Okay? Does that make sense? In other words, this works for non-right triangles is when we usually use it, but it really works for what? All triangles. And y'all know that. That's that some old hippie caught another hippie tripping on acid. Is that the one y'all remember? Some of y'all laughed, some of you didn't. I can't tell. You got masks on. All right. Not a right triangle. Let me draw one. Let's make that 6. Let's make that 7. And we'll make this side over here 11. Which, somebody says, Mr. Evans, at least label them closer to what they are. The longest side, 11, we got a triangle. We know 3 sides. And we want to know the angles that are inside of there. And it's not a right triangle, I don't think. You can check it. You can do a squared plus b squared, see if it equals c squared. I don't think it does. I'm not pretty certain it's not. But here's what we want to do. We're going to use one of the laws, and we'll teach you the laws today. But we're always, if we have 3 sides, we are always going to find the largest angle first. If you don't know any angles at all, always find the largest angle first. Now, the largest angle is always going to be what? Opposite to what? Largest side. Now, honestly, you can find the smallest angle first, but you can run into problems. You get into these, there's a whole group of sine angles that are a little bit weird that we don't want to deal with yet. So always do what? Find the longest side, find the largest angle first, which will be what? Opposite the longest side. To do this, we're going to use something called the law of cosines. And here you go. This is one of the biggies. This is one of the laws you're going to write on the back of your unit circle. The laws that we're going to give you today, you're going to write on the back of your unit circle. C squared equals a squared plus b squared minus 2ab cosine theta. Now, I'm going to tell you the good news. If you look at a textbook, there's 3 formulas for law of cosine. You don't need to know them all 3. You need to know this one. And here's why. You can make any one of the sides, this C. You could use 6 and find this angle. You could use 7 and find this angle. All right? The catch is this C side, whatever side you pick for that, is always opposite that angle. They have to be opposite each other. So if you put 7 in right here, then that angle that you're going to be finding is going to be what? That angle. Is that okay? And that's the key right there. Here's why. In the textbook, they tell you there's a formula for a squared equals c squared plus b squared minus 2cb cosine of alpha. Well, all they're doing is if they put an a here, they got to put angle alpha over here, right? It's the same pattern. Just learn it right there. Now, so what I do, and we might need calculators today. God, I hate that thought. Is I do 11 squared equals 6 squared plus 7 squared minus 2 times 6 times 7 cosine theta. Now, some of y'all get your calculators out and do a little too much too fast. That's going to be 121 equal 36 plus 49 minus 6 times 7 is 42 times 2, 42, 84 cosine theta. Now, do you agree you're going to subtract both of these from the 121? Is that okay? Don't subtract it. The 84 is multiplied by that, so that's where some people make a mistake. 121 equals, I got to add those together first. 85, is that right? Yeah, it's 85 minus 84 cosine theta. Subtract 85 from that, 36. So 36 equals negative 84 cosine theta. Cosine theta equals negative 36 over 84. But you want to know what theta equals. In your calculator, see, you're not taking the cosine of the angle, okay? You want to know what the angle is. Do y'all know on your calculator that you have that inverse cosine key? If you look on your calculator, you got a cosine key, and then above it you got a cosine -1. That means the inverse. So what you want to do here is you want to do that inverse key, and I'm going to call it arc cosine, because I hate that inverse notation, of negative 36 over 84. And you can punch it in your calculator. And on your calculator, I think you have to hit the second button and then hit it, right? Now, something that you may want to make sure about is that your calculator is in degrees. Because, yeah, yours is in degrees, okay?
Where's the button now?
Okay, you got a second button?
Yes.
Then hit your cosine button.
Oh.
Then put the number in.
Okay.
That's inverse cosine. That's arc cosine. All right? And what did y'all get? 100 and what? 115 degrees. And I know you're supposed to carry them out to 4 decimal places, but for me, right now, well, what did you get to 4 decimal places?
3, 7, 6, 9.
3, 7, 6, 9 degrees. Put your little degree symbol up there. Okay. Now someone says, well, Mr. Evans, couldn't we do the same thing and find this angle too? You could, but we're not going to do that hard work anymore today on this problem. If you ever use law of cosines more than once in a problem, you're doing it the hard way. All right? You only want to use law of cosines once if you have to. Everybody hear that? Make sure. All right, so we know that angle, and we want to find the other angles. Yes, you can find the other angles by using law of cosines, but you don't want to. That'd be a lot of work. I'm going to show you an easier way to find the other angles. Someone got a question about this part? You better raise your hand now, because we're rocking and rolling out of here. Thompson is on the midnight highway, letting the beast roll. Y'all don't know where that came from because y'all don't read enough, but that's okay. Anyone? Okay, so what we're going to do is we're going to talk about what's called the law of signs. Part 1. I'm going to joke, this is law of signs part 1. Because there's actually a part of the law of signs that they don't teach you very often, but I'm going to remember to teach you. Okay. The sign of alpha over the side opposite it equals the sign of beta, sign of beta, over the side opposite it, or you can do the sign of beta over C. Now, when they write this in a book, students freak out because they go, well, Mr. Evans, we got three parts. No, you don't. When you work it and you actually use it, you're going to use this part and this part, or you're going to use this part and this part. You're never going to use all three of them at one time. You're just going to use two of them at a time. Everybody hear that? And just in case, you realize if you take the reciprocal of all of them, they are still equal. And the reason I'm going to point that out is because I got a way that I'm always going to set these up. So if you're looking, you can do them, write them this way, or you can write them this way. Is that okay? Now I'm going to tell you the part that I want to teach. Whatever I'm looking for, I am always going to put in the top left corner when I write these out. Whatever I'm looking for, I'm going to always put in the top left corner. All right, I'm about to erase all of that. We're worried about that. Okay, I'm about to write 115 degrees. 115.36. 3769 degrees. All right, here we go. We're going to find the side opposite 6 now. I'm not going to erase those laws. Let's erase this right here. All right. Now, I'm going to find this one. Now, so that's the one I'm looking for, right there. Okay? Looking for that one. So I'm going to do sine alpha over 6 is equal to the sine of 115. Now you realize if you don't get that one right, you're in trouble. Over 11. See, you could, and this is an easier formula. It's real fast. Now,
oh, you use the sign, but oh, never mind.
Is that cool?
Oh, yeah, I was about to ask where you got the 115 from.
See, yeah, now you could have kept using law of cosines if you don't need to. Once you do law of cosines, if you have to, students always ask me, how do you know which law to use? I always try to use law of sines first, and if it won't work, law of cosines. But I'll just tell you real simple. If you don't know an angle and a side opposite it, you got to use law of cosines. As long as you know an angle and a side opposite it, you can use law of sines, usually. All right, so sine of alpha is going to equal 6. It's going to equal 6 times sine of 115.3769 degrees over 11. You punched all of that in your calculator. And the sine of alpha is going to equal all of that decimal that you're about to get. I'll be honest, on the ACT test, they just ask you which equation will work to find it, and they'll have it, and you just pick it out and bubble that one in. You don't actually work it out. Okay, once you get that decimal, how are you going to actually find the angle? You're going to hit that inverse sine key. That's what that means. Arc means inverse sine key of the decimal, and you will get alpha equals. Somebody tell me what you get for the angle. I don't care about the decimals. Sorry? So learning mode. Okay. You got, what decimal did y'all get here? Point something, what'd you get?
I can't remember, I ended out.
Oh, okay, you've already got the angle?
I think it's right.
Okay, what's the angle?
I got 29,
29 point something?
5,
Point 5 what?
26. Wait, 29.5, 26.
Okay. How many people got 29 point something? Yeah, and some of y'all are going to say, well, Mr. Evans, they're going to be a little bit off. Yeah, everybody just carried out 4 decimal places, and we'll at least be good with the whole number. Now, once you know those two angles, do you have to do any of this trig to find the third angle? No, because you know they do what? Add up to 180. Now, I'm going to warn you. On this problem, if you had not found the largest angle first, you could have ended up with some weird stuff. Okay? You always want to find the largest angle first. Everybody hear that? It just saves you some hassles later on. I'm not even going to find the third angle because, well, it's 100. Round that off to 30, round that off to 115, so that's 145. So this would be a 30 by 35 degrees down here. And I know it's not exactly 35, but it's going to be real close, right? Okay. Now, happy so far? They happy? All right, well, let me tell you something kind of cool. This is part 2 of the law of sines. Law of sines, part 2. Part 2. Law of sines, part 2. If you were doing laws, okay, I want to find the area of the triangle. Well, I would have to have a base, and then I'd have to I'd have to figure out what the height was, wouldn't I? It'd be kind of a pain, wouldn't it? Right? Not a lot of fun. Okay. The area of a triangle will equal 1/2 AB cosine of the angle, sine of the angle between them. Sine of the angle between them. In other words, the area of this triangle would equal 1/2 6 times 11 times the sine of 35 degrees. Somebody says, no, Mr. Evans, I did. The area of the triangle equals 1/2 6 times 7 times the sine of 115 degrees. Guess what? You will get the same answer. It just has to be what? Side, angle, side. The angle that you put here, has to be between those. In other words, it has to be like this. A, B, theta. Side, angle, side. As long as you got that, that will tell you the area of the triangle without you having to worry about base and height and all that. That is a lifesaver. That is a saver. Lifeguard. That is one of those formulas that if you know it, that question is on the ACT. They actually have a question on the ACT, whereas if you know this formula, you just punch the numbers in. If you don't know this formula and you have to work it with the old 1/2 AB, or 1/2 base times height. It can be done that way, but folks, it's a hassle to find that height. Okay? You don't want to have to find that height. All right? It can be done, but it's a lot of steps. So that's one of those formulas you put in long term, save it in your brain. There will be a calculus formula in college. Okay? And the formula you're going to have in college is going to have two sides of a triangle, and then the angle between them is going to be growing, like this. And they're going to talk about how fast that area is changing. Here's your formula you're going to have to use right there. Okay? Know that formula. That's the law of sines part 2. Okay? Now, the good news is sometimes what I always tell students is try to use law of sines. If it won't work, try law of cosines. But then again, Mr. Evans, it's a little bit late. All right. Mr. Evans is out in the mountains, and he looks up. That's called an angle of elevation, by the way. When you look up, that's called an angle of elevation. You're looking up. An angle of depression, you're looking down. He looks up, at the top of the cliff, top of the mountain, and he measures the angle from where he's standing. This is a right angle, by the way. That's pretty cool. That is a right angle. So, you know, might be able to use some of our other formulas. But anyway, he looks up. An angle to the top is 30 degrees. All right? He walks 100 yards, 300 feet. He walks 300 feet to right here. So he walks from here to here, which is 300 feet. And he looks up again. Well, if he could draw, it would help. He looks up again, and the angle that he has is 60 degrees now. Wow. And we want to know how high the mountain is. Okay. This probably wasn't the problem I should have worked. We want to know how high the mountain is. Here's the whole deal. If I knew this distance right here, I'm going to call this x. Do y'all agree I could do the tangent of 60 degrees is equal to h over x? Okay? I don't want to know that. That's too hard. Let's do this. Let's talk about this. Maybe if I don't do it that way. See that y right there? If I knew that y, then I could do what? Sine of 60 degrees is equal to what? H over y. It'll work if you do either one. Tangent 60 degrees equals h over s. I'm going to go ahead and write that up there. I should have erased that, but I did. But do you realize it could be pretty easy to find the y value right here? It might be easy to find the y value. Okay? And here's what I'm getting at. I know that's 60, so do I know how much this is?
Yeah.
How much is that?
120.
120. Okay, I'm going to put everything that I'm going to have to find out in a different color so we can kind of watch. That's 120. Well, if that's 120 and that's 30, oh gosh, that means this is just what? 30. Well, if that's 300 and that's 30 degrees, how much does y equal? They're both opposite, okay? The drawing's not right, the drawing's not very accurate, but if that's 30, that's 30, they're equal to each other, aren't they? Okay, I meant to draw this to where you would have to use the law of sines. I meant to, for you to have to do sine of this angle equals 300 as sine of this angle equals what? This side over here. I meant to, for you to have to use law of sines there. I didn't make a very good problem, did I? So if you know that's 30, then, or 300. Chalk, easy. Mr. Evans screwed up, didn't make up a good problem, did he?
Oh, because it's equilateral.
Yeah, see, I shouldn't have made up an equilateral triangle because you didn't have to use what? Law of sines. I was trying to make a problem where you'd have to use what? Law of sines. So we're going to make up another one. All right. Mr. Evans realizes that he measured the angle wrong. And when he looked up, the angle was not 60 degrees. The angle was only 45 degrees. He had measured the angle wrong. The angle was only 45 degrees. He had screwed up. He was walking around out in the mountains. Folks, when you go to the mountains, don't expect your GPS to work. Yes, I have wandered into people in the mountains, walking around trying to find a place where their GPS works because they don't know how to look at a map. Okay? Your GPS may not work in a lot of parts of the mountains. Okay? And you may not have phone service to call and go, please come get me. All right? Now, with that in mind, that's 45, so this is what? 100 and what? 35. Yeah, 135. If that's 135, that's 165, so how much is this one up here? 15. And I want to find this side right here. I'll call it X this time. I want to find that side right there. Yes, sir. Yes, sir. So what I'm going to do is I'm going to do X over sine of 30 equals 300 over the sine of 15. Now, you will notice something I did here. I used the reciprocal version because I always want to put what I'm looking for where? In the top left. Do you have to do that? No, but I'm trying to make it what? Easy. So, X equals the sine of 30 times 300 over the sine of 15. Don't you dare try to reduce that. You got to do sine of 30, sine of 15. You can't reduce those.